So now we're going to look at Python built-ins, and for this one we're going to use capital S for set and capital L for a list. The first bullet point here is to examine the constant efficiency time, so O of 1. And you can see that the first example is looking at the length of a list. So if we create L as being a list of 2, 3, and 4, when you create this list L, it actually embeds or remembers the length of list L as like a quality or characteristic associated with this list L. So therefore, whenever you call this built-in function, length of list L, it actually references what it already found when you created that list L. That's what Python does automatically, which is nice. So therefore, this is going to be O of constant time, O1. Next, when you look for values in sets, remember that we learned that when you create a set, let's say it's going to be a set of immutable values, because sets can only contain immutable values because you hash these values to a location in memory, and therefore the hash values must always rely on an unchanging element such as an integer or a string and not a list. So when we want to say whether 30 is in S, which is going to be true, it's going to accomplish this by membership actually instead of sequencing. It's going to look for the hash value of 30 and check to see if the corresponding hash bucket essentially in S is occupied, and it's going to return true if it is. So therefore this right here, print value in S, val in S, this operation is going to be constant time as well, which is really nice for sets, because this is the clear advantage that you have for sets over lists, because you can see that it's moving faster. The last example here is when you append an item. So if we have L, I'm going to add 10 to our list L. It knows exactly where to add this parameter 10. So it's going to go to the end of it and add it in. Therefore, this right here argument is going to be constant time as well. Okay, so now the next step here is n time, where capital N is going to be the length of the list. So you have these functions max and min of L, which essentially goes through the list L that we have here and looks for list L here and tries to find the minimum or maximum. So therefore it can only achieve that if it goes through the entire length of the list, right? So therefore finding the minimum and maximum must be the length of the list, which is going to be O of big N. And if you also want to say print for an L, you're only going to return true once you go through the entire list L and compare that to this parameter 4. So therefore, looking for values in lists now is going to be constant big N, or sorry, O of n time. So this right here is different than 30 in S, because 4 in L must be going through a sequencing search until it reaches the end, which is why it's the O of big N, whereas 30 in S is going to be looking for membership, so it looks for the hash value. And counting a value, so if you say print, count how many times a value occurs in S, that's also going to have to go through the entire list of L, making it into a set of L also, so S2 equals a set of L. You're going to have to take every single element inside list L, 2, 3, and 4, and hash those values to be put into a new set called S2. So therefore, this is also going to take O of n time. And finally, the last example is sorting, which is built-in. This is going to be a destructive function. So we say you can sort L.sort. Oops, that returns none because it's destructive. But if we just sort it and we print L, this right here is going to take n log n, because the built-in sort in Python actually uses a hybrid of merge sort, which is n log n. So therefore, this line right here takes O of n log n, and that's something we should know as the built-in sort function in Python. You can also see a more complete list right here, so you should click on that link and take a look at all of the other built-in other built-in methods in Python for both lists and sets, and that was for lists right here, and see if those make sense to you, and sets, but there are different ones to highlight, different ones to watch out for. but it's good to know or have a general idea of most of these built-in functions in Python.